how we can define hybridization and how to calculate hybridization we are going to do now. Okay. So generally, after types of bonds, no, general hybridization is used for okay. Hybridization we are going to use it for the to find the geometry of the molecule. Okay, na? To find what is the geometry of the molecule. To study that, we are going to discuss about the hybridization.
Sir, yesterday you told you would discuss formation of covalent bonds today, na,
Covalent
sir?
bonds, sir.
Yesterday I told you know how it is formed.
No, sir.
No, sir.
You would discuss today.
I haven't discussed covalent bond.
So
You
covalent bond over,
discussed,
sir.
sir, but you
Formation
did
is not
not.
over.
Hello.
Yes, sir. Formation is not over. Formation of covalent bonds.
Acha, that means valency bond theory. Am I discussed or not? Tell me.
No, sir. Yesterday we completed dative bond. So now you told formation of covalent bond.
Acha, formation of covalent bonds and how it is going to form. That means how valency bond theory is going to discuss. That only, no?
Yes, sir. Maybe.
Am I discussed about valency bond theory?
No, sir.
No,
No,
sir.
sir. No, sir.
Okay, that means how valency bond theory it will there, how it is going to overlap it will form.
Sir, we don't know, sir.
Okay. From that one overlapping, how it partial overlapping, lateral overlapping. These all we haven't discussed, right? That only Nanu you are trying to say.
Yes, sir.
Okay.
Yes, sir.
Mm. Okay. Actually, so after discussing about the octet rule, etc. Okay. So after discussion about the octet rule and how the bonds are going to form. Okay. Once covalents are bond formed, that means what covalent bond is formed by the mutual sharing of electrons, right? Mutual sharing of electrons, covalent bond is covalent bond is going to form. Generally, this to explain this covalent bonds only. So, what are the parameters we are going to use? On which basis we are going to define this? Okay. So, what are the valency bond theory and what are its points? Okay. From this one, how sigma bond is going to form? How the uh, pi bonds are going to form? These points we need to discuss. If I'm not wrong. Okay. So, let's start our topic today. So, valency bond theory. Actually, this valency bond theory is mainly explain the uh, valency bond theory, whether it is valency bond theory or molecular orbital theory or valency shell electron pair repulsion theory. These all theories we are going to discuss for the molecules about its structure. Okay, how it is going to form. So, valency bond theory. Valency bond theory. Generally, this was proposed by Hitler and London. Okay, this was proposed by Hitler and London. Okay, and this theory mainly explains the how covalent bond is forms. Right? To explain the formation of covalent bond. Okay, na? Mm, From this one, what we can see here. So in that one, what are the main points? Just focus on this point. So according to this, a covalent bond is formed by the overlapping of atomic orbitals. First point is a covalent bond is formed by covalent bond is formed by overlapping of atomic orbitals of valence shell. Atomic orbitals of valence shell. Okay, atomic orbital of valence shell. Okay. So in that overlapping process, what we can say, simply half filled atomic orbitals only, uh, half filled atomic orbitals only will involve an overlapping process. Okay. So as a result of overlapping, what will happen? The density of electron plate see, as a result of overlapping, the density of shared electron pairs pair is concentrated mostly on the internuclear axis. Okay.
Sir, 1 minute. Sir, could you explain the last point?
Actually, what did I say? For example, as we know, the electrons are in the terms of electron density will be there like this, right? Okay, na? So electrons around the nucleus will be in terms of density. Okay, like this electron cloud will be there. Now, two atoms are there. Let me take this is A atom and B atom. In that one, valency electrons with unpaired valency orbitals with unpaired electrons will come and they will partially overlap like this. Overlapping means that becoming higher dense along with one axis, along either x-axis or y-axis or z-axis. Okay, na? So because of this, what we can say, for example, let me take, so this is x direction. Now here one atom having electron density like this and B atom also having electron density like this. Okay. Now when they are opening, no, so along this density, what happening? See here, electron density increasing or not? Likewise.
Yes,
For
sir.
example, let me take, this is electron density in this way it is there for atom. And for B atom it is there like this. So in the circular path. Okay. Let me assume like this. So when they are overlapping, now see here, they are overlapping like this. This is the internuclear
The
area, right?
density is becoming big, sir.
In this one, what we can say here, the electron density will be more as compared to between these two.
Yes, sir.
That only he said. Okay, the electron mostly internuclear axis, the electron density will be more.
Sir, the internuclear axis means the between middle part, sir, between the two circles.
Yes, that means in which axis they are joining, like along x-axis or y-axis or z-axis, like that.
In the diagram where the density is more, that is the internuclear axis,
Yes,
sir.
yes.
Okay.
Okay. Next, what we can say, as a because of the what we have written, mostly in the internuclear axis, as the overlapping, the resultant bond uh, acquires acquires a pair of electrons with opposite spin. Okay. Next, greater the overlapping, greater the extent of overlapping, greater the extent of overlapping, greater the uh, greater the extent of overlapping, stronger the bond formed. So stronger the bond form. Next, uh, the electrons in bond formation are equally attracted by the both the nuclei. So have you understood what I'm trying to say this point? That means the nuclei means what? The centers, no? So these two electrons, that electrons which are involved in the bond formation, no? That is attracted by the both the nucleus. Okay, na students?
Sir, once can you show it in a diagrammatic way?
1 second, let me complete this. I will show you that how the overlapping will take place. Okay, na?
Okay, sir.
Mm. Next point is, mm, next what we can say, the amount of energy released per mole uh, during the overlapping process is called, during the overlapping processor during the overlapping process is called bond energy. Mm. Next one, next one. Generally, The bonds are formed mostly in the direction where electrons are concentrated. Okay. Now let me check this. How to do that overlapping? No.
Sir, could you explain the fourth point? Bond energy point.
1 second, Anna. Bond energy means it is overlapping will takes place. No. Okay. During overlapping, how much energy is releasing?
Oh, okay, sir.
That is only we are saying that. Can you see, students? Hello.
Yes, sir.
Can you see my screen?
Yes, sir.
Where that cursor is moving?
Yes, sir.
Now see here. Now if you observe clearly, this is s orbital, right?
Yes, sir.
So this s orbital, that means the green color is there, no? That yellow color which you are able to see, the dot, is
Yes,
nothing
sir.
but center of the nucleus. So if
That
I'm
is the
take
nucleus, no, sir?
center of nucleus, and remaining green color part is there, no? That is what we can say orbital, and electron cloud is there.
Sir,
Okay,
where is a green color, sir?
green, blue color.
Oh, okay, sir.
Okay, this blue color is there, no? This blue color represents the electron density. Now see, this is atomic orbital of 2s orbital of an atom, and this is of another atom. Okay. Now if I'm taking these two are resultant or overlapping, right? Like this. See?
Yes,
In
sir.
the overlapping, see, in the middle area, you can see that more electrons are there.
Yes, sir.
Yes or no? And
Yes,
see,
sir.
and along these two axes, that means see, from these two nucleus, in that along the axis only, along the, for example, two nucleus are there. Along the two nucleus, if I'm assuming an axis, we are able to find this distance is there, no? In this one. What happened here? So in this internuclear distance, the electron density will be more. Now see, if I'm taking sp overlapping, if I'm taking. Now see, s orbital is there like this, and we know p orbital will looks like this, no? Dumbbell orbital. Now see here, in the blue color they are.
So p orbital looks like dumbbell, sir.
Yes, yes. Okay. Now see, this blue color is getting overlapping, no? As compared to yellow color.
Yes, sir.
This we are saying that sp overlapping we can say. Okay. Now see here, in this one 2p orbital, see here. Here blue color part is indicating, no?
Sir, in the p orbital, blue represents s orbital and yellow is
No,
p,
no,
sir.
no. This circle one represents s orbital. Generally in p orbital, how we are going to write? Let me write once.
Sir, parts of shells of electrons only, they will only combine, sir.
Yes,
Means the
see, these are
orbitals are
p
part.
orbital. P orbital, no, it will looks like this, which we have seen in structure of atom. Okay. So this is actually positive lobe we can say, and this is negative lobes. Okay, because this is negative axis, right? And
Yes,
this
sir.
is
Negative x-axis.
this is positive axis, right? So that's why we can say the electron density along this positive side we can say as positive lobe, and this is negative lobe. Now in this diagram, if you are observing in the p orbital, see here. If I'm taking, let me take the blue color one is positive lobe, and yellow color one is negative lobe if I'm taking. Now see here, in this one also positive part and negative positive part only getting overlap. I want to convey.
Yes, sir.
Whereas in this one, see, two people I'm taking, no? Let me take this blue color is positive, no? So in this one, see, positive part only overlapping, not positive, negative, isn't it?
Yes, sir. Sir, I
Likewise,
have
if I'm taking, for example, say this is positive, this is negative, and one more if I'm taking, no, so this is negative and this is positive. If I'm representing like this, these two can overlap. Okay, these two can overlap. Okay, these two
sir,
can overlap. Okay, na. So this we are saying, see, negative lobe and negative lobe. This type of overlapping is known as positive overlapping, we can say.
Sir,
1 second, let me finish and after that you ask your doubts. Now let me take here. For example, this is positive part and this is negative part. And here we have negative part and here we have positive part. And if I'm trying to overlap these two, no, this overlapping will be minimum
negative,
overlapping
sir.
will be there, and that we can say as a negative overlapping. That means in this diagram, in 2p orbitals, no, if
Positive
blue color
overlapping, sir.
or yellow color are overlapping.
Positive
What I come again?
overlapping, sir.
अरे यार, positive overlapping it is. Okay, na? If yellow color and yellow color only overlapping, that is also positive overlapping only.
Yes,
Are you
sir.
getting what I'm trying to say? If yellow color and blue color is
Negative
overlapping,
overlapping, sir.
that we can say as a negative overlapping. See here, understood what I'm trying to say? What is overlapping?
Yes, sir.
sir, I have one doubt.
Tell me.
Sir, orbitals are part of the shells, no, sir. So only the valency shells orbitals will overlap, sir.
Yes, that is only said, no. In the bond formation, only valence shell electrons only will involve. That to be with unpaired electrons only.
Sir, 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 in one shell there are many orbitals, no, sir. Only one orbital from one atom and one orbital from another atom. How can they combine, sir?
That I will
Many
tell you,
should
no.
combine.
First, you try to understand what is meant by overlapping and how types of overlapping.
Sir,
In a molecule, how overlapping will take place, I will tell you now.
sir. Okay, sir.
Uh,
Sir, if here in the third example, if blue and blue overlap, it is positive or negative, sir?
positive.
And yellow?
Positive only.
Sir, there will be no blue and yellow, sir.
That one I'm telling. If blue and yellow is overlapping will takes place, that will become negative overlapping.
Okay, sir.
Okay, na?
Opposite
And
means
that
negative.
overlapping will also be very less actually. It will form very weak bond. It will form. Okay.
Sir,
Yes, sir. Thank you, sir.
Next one more say. This is one type of overlapping, and actually this overlapping we are saying, no, where we can observe maximum. That overlapping is known as end-to-end overlapping, and one more is there, that is lateral overlapping. Lateral overlapping. That how it will form? Let's see that. Now see here. If you observe now here, see Nana, this one. First see this one. If you observe this, see here, this is p orbital, no? This is end-to-end overlapping, we can say. End-to-end or head-to-head. You can take this. In the bottom one, you can see no blue color. Can you see, student?
Yes, sir.
yes, sir.
This
Both
bottom
the
color is the blue color overlapping. This is known as head-to-head overlapping, nahi to, or end-to-end overlapping, we can say. Okay, na? This end-to-end overlapping or head-on overlapping will result in a sigma bond, which is a stronger bond.
Than pi bond, sir.
Let me say what is pi bond. Do you know what is meant by pi bond?
Sir, head to head means it's a sigma bond, sir.
Yes.
Okay, sir.
Okay. And now see, this is p orbital, right? Now see here, if you observe clearly, see how my cursor is moving. See this area you observe, the intersection area of green color and intersection area of the light color, light blue or light green color, this one. This is very less, right?
Yes, sir. Middle also not joining.
Middle also not properly joined. Whereas in the bottom one you can see the intersection area is little bit larger, no, as compared to above the diagram.
Yes, sir.
That we can say stronger extent of overlapping, we can say. Understood what I'm trying to say?
Sir, that means both types of overlapping can happen.
Yes. Okay, na? Understood what is meant by overlapping and etc.
Yes, sir, but do they have specific conditions for each bond?
Yes.
Okay, sir.
Okay. Now let's come to this. Now what we said. Okay. There are, what did I say? Na? There are two types of overlapping is there, na? There are two types of overlapping is possible. One is what? End to
Head
end,
to head, sir.
end to end, or head on overlapping. You can say anything. Or head to head overlapping also you can say. Which results a stronger bond called sigma bond. Next one is sideways or lateral overlapping which results a weak bond called pi bond. Okay, weak bond which is called a pi bond. Okay, na? Simply, I will try to write how end-to-end overlapping will take place. Simply in diagrams, I'm trying to find out. Okay, which we have shown, no, that I'm trying to end-to-end overlapping. How it will be there here. So this is s orbital. Let me take, and this is one more s orbital of same or different atom. Okay, this is x. This is s orbital, and next what we can say, this is x, y, z direction, and x direction or y direction. The overlapping should always takes place in one direction only, either x or y or z. Okay, which results this is sigma bond. This is called ss overlapping, we can say. That means the overlapping is between s and s orbitals. Now let me take p and p orbitals.
Sir, one go to previous slide, sir. One, please.
1 second, Nana. This is p orbital. Let me take x. This is px orbital, and one more is there. This is also px only, x direction, and which we can say as px, which results in this is pp overlapping, we can say, which forms sigma bond.
That means a head to head overlapping, no, sir.
Yes. Done?
Yes, sir.
Sir, 1 minute, sir. Sir.
Okay. Next, let me take a S and P. This is S orbital. Now see, all overlapping is in one direction only, no? That is either X direction or Y direction or Z direction, right? Yes or no?
Yes, sir.
So that's why the covalent bond is always in either X direction or Y direction. That means covalent bond is directional in nature. See, whereas ionic bond is non-directional, no? Do you remember? Do you remember, Nana? Ionic bond is
Yes, sir.
non-directional because
That's
the
why I also
attraction.
said I remember the structures instead of formulas.
Uh, okay, na? So that means what we can say. Diagrams కొద్దిగా ఆడతేడా వస్తేనే చూసుకోండి అనేది. So this is what we can say lateral overlapping. Okay.
Sir, 1 minute.
Which results pi bond.
Sir,
Uh,
sir, that means the type of orbital, uh, the type of orbital depends on the shape of the covalent bond.
what you are trying to ask, Nana? Covalent bond we can't define shape. Okay, we are trying to form covalent bond, how it will form. Okay. So
That
in that bond formation also there are, as we said, no, sigma bond also there, pi bond is also there. So sigma bond means stronger bond. So how he is saying that covalent bond will form by the overlapping phenomenon. So how this overlapping will takes place, that we have seen till now. So in the overlapping also, if the overlapping is strong enough, that is can say it will form strong bond. That we are saying that head-on overlapping. If the overlapping is weak, that we can say pi bond we can say. Okay, these are only imaginary only.
okay, sir.
So this is about the next. So this is about the bond formation, etc., etc. Now in this one, so let me take, as we have seen sigma bond and pi bond we have seen, no? So what are the differences between sigma bond and pi bond? Let me write. Okay, differences between sigma bond and pi bond. So after this, how sigma and pi bond will form, by which orbital overlapping in sigma and pi bond will form in molecules, we will see that. Okay, na? Differences in sigma and pi bond. Let me write like a table. Sigma bond. This is pi bond.
Sir,
Sigma.
that is symbol, sir.
Which one, Anna?
Sir, you wrote sigma bond, no, sir. That is sigma symbol, sir.
Yes, sigma symbol and pi symbol.
Yes, sir. Pi we know, sir.
Sigma bond, how it is formed? It
Sir,
is
by uh, oh,
by End to end overlapping, right?
End to end overlapping, sir. Head to head.
End to end overlapping. Next, pi bond will form
Lateral overlapping,
by
sir.
lateral overlapping. By lateral overlapping of orbitals. Okay. Sigma bond is what? It is a strong bond, right? And pi bond is what? Relatively
Weaker bond, sir.
pi bond is relatively weaker. Next, there can be free rotation along the, there can be free rotation along the sigma bond. Free rotation is not possible along pi bond. Okay. Next, what we can say? Sigma bond electrons are sigma bond electrons are localized electrons. Localized electrons. Localized means it remains as it is. It will not change from one place to another place. Okay. Whereas pi bond electrons are mobile electrons. Mobile means it will move from one place to another place. Next, sigma bond has independent existence. And then this one, pi bond exists along with sigma bond. Plus pi bond alone, it doesn't exist along with sigma. Okay. These are the, okay. Okay, now students. Students, okay, Nana?
Yes, sir.
Yes, sir.
Clear అయింది కదా? Have you understood now what did I say? This is about the sigma bond and pi bond. Okay. Next class లో ఏం చేసుకుంటామన్నా, we can discuss about how sigma bonds or pi bond formed. We have discussed, right? And in molecules we are going to see how sigma bond and pi bond, how overlapping will takes place, in which orbital we are going to form the overlapping. Okay.
Sir, once could you explain how pi bond exists along sigma bond?
In tomorrow, first in any molecule, no, first it will form sigma bond only. Okay. After formation of sigma bond only pi bond will form. Without forming sigma bond, pi bonds cannot form.
That tomorrow you'll show, sir. How?
I will show you tomorrow. But remember always, whenever between two atoms, if one bond is formed, so it will be always sigma bond only. If
Yes,
it is
sir.
two bonds, it is forming. One will be sigma, one will be pi. This we know, I think, right?
Okay, sir.
Triple bond means what? One sigma and two pi bonds.
Okay, sir.
Yes or no?
Yes, sir.
Hmm. So these pi bonds are always formed after formation of sigma bonds only. Okay, na? Okay, na, students?
Okay, sir.
Yes, sir.
Okay, students, you can leave. We will meet you in tomorrow class.
Thank you, sir. Bye.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir. Good night, sir.
Students, relax 5 minutes.